Let's solve this question. Sin inverse 2x upon 1 plus x square. So here if you see that 2x upon 1 plus x square is given. So we can make use of sin 2 theta formula. Okay. So in place of x you have to put tan theta. So it becomes, so our dx is d theta. Okay. I'll write here and this formula is sin 2 theta. Okay. So we can dx you have to write x square theta d theta. Okay. Sin 2 theta. So this becomes 2 theta into x square theta d theta. Okay. 2 we can keep outside, and for this you can use integration by parts formula. So theta, this is u, this is v. Integral of x square theta d theta is tan theta minus integral this integral of sec square theta d theta into derivative of theta, which is 1. Okay. Integral of tan theta is log sec theta plus c. Okay. Now we have to resubstitute theta. So theta is what? Tan inverse of x. Okay. What about sec theta? If your tan theta is x, so this becomes x by 1, right? So if I use the triangle method, this is theta. Tan theta is opposite upon adjacent. Opposite upon adjacent. So what will be the hypotenuse? Root of 1 plus x square. Correct? So using this triangle, you can write sec theta, which is hypotenuse upon adjacent. So root of 1 plus x square. So in place of sec theta, you have to use that. Theta is tan inverse of x into x minus log sec theta is root of 1 plus x square plus c. Okay. Next question, integral x upon 1 plus sin x dx. Okay. So here we can multiply by, we can remove this 1 plus sin x by multiplying 1 minus sin x in the numerator and in the denominator. Okay. So x into 1 minus sin x, a plus b, a minus b. So this becomes 1 minus sin square x. So using trigonometry, 1 minus sin square x is cos square x. Okay. So we can write this, separating the denominators, you can take this x inside. So it will be x upon cos square x minus x sin x upon cos square x dx. Okay. So x 1 upon cos square x is x square x dx minus x sin x upon cos x is tan x, and 1 cos x remains, 1 upon cos x, that is sec of x. Okay. Now for this you can make use of again integration by parts. Okay, this is u, this is v. So this is x integral of sec square x dx is 10x minus 10x into derivative of x, that is 1. What about this? Here also you have to make use of integration by parts. Okay, so here it will be, this is the derivative of sec of x, right? So it will be the integral of integral 10 of x into sec of x is sec of x. Okay, so integral of 10 of x into sec of x is sec of x. This is u and this is v minus integral sec of x into x is 1. Okay, so this is x 10x. Integral of 10 of x is log mod sec of x. Integral of sec of x is log sec of x plus 10 of x plus c. Okay, so you can take this minus inside, so it will be, this will be minus and this will be plus. Next question, I is equal to 0 to pi by 4 log of 1 plus tan theta d theta. Okay, so here you have to make use of the property of definite integrals. That is, if you are given 0 to a, okay, or a to b, then you have to make it f of a plus b minus x. Okay, so in place of theta, you can write 0 plus pi by 4 minus theta. So it will be pi by 4 minus theta. Okay, this is tan a minus b. So tan a minus tan b upon 1 plus tan a into tan b. So tan a, tan of pi by 4 is 1 minus tan b upon 1 plus tan a 1 into tan b, tan theta. Okay. So cross multiplying, you will get 1 plus tan theta plus 1 minus tan theta, 1 plus tan theta d theta. Okay, so 2 upon 1 plus tan theta, which you can write log of 2 upon 1 plus theta, log of a upon b, log a minus log b. Okay, so this thing you can integrate constant, right? What about this? This is our original integral. Okay, so I can write in place of this I, and here also there is I. This we have to integrate. So log 2 is constant. So integration of 1, which is theta. Sorry, this is pi by 4. So if I take this minus I this side, so I plus I, 2I log 2 into pi by 4 minus 0. Okay, So the final answer is I equal to pi by 2 log 2. Oh, I made a mistake. This 2 will come here and multiply. 8, pi by 8. Okay. Next question, 0 to pi 4x sin x upon 1 plus cos square x. Okay. So here also you have to make use of the property, same property. Okay. So I can take this 4 outside. Pi minus x, pi minus x dx. Okay. Now we are changing this pi minus x. This is pi by 2, this is pi, right? So it is in the second quadrant. So this is like whenever there is pi and 2 pi, we don't have to change this. Okay. And in the second quadrant, sign is positive. So this remains same. Let's write this. Okay. So next step 4. So we can split this, right? So sin x into pi and sin x into x. So we'll get two integrals. Okay. So if I write this 4 inside, it will be 4 pi and this is also 4. Okay. So this is our original integral. So I can write here I. I. Okay. This I comes here, so it becomes 2I. And this 4 pi is constant term, so I can write it here. Next is you have to make substitution here. Okay. So I'm taking cos of x as t. So cos of x minus sin of x dx is dt. Okay. Also you have to make changes in the limits. So when your x is 0, t and cos 0 is 1. Okay. What about x pi? T is minus 1. Correct. This is I upon 2 pi. Here it changes to 0 is 1 minus 1 minus dt upon 1 plus t square. Okay. Again you have to make use of the this our definite integral property, that is if the integral is given a to b, then you can write it as minus b to a. Okay, limits interchange. So this is already minus, so I'm taking minus over here, so it will become plus, right? And our limits change from minus 1 to 1. Okay, so this is integral of 1 upon 1 plus t square is tan inverse, right? So take b first. So tan inverse of 1 is pi by 4 and tan inverse of minus 1 is minus pi by 4. So this become plus pi by 4. So this is 2 pi by 4. And here it is I upon 2 pi. Okay. So I you can take 2 pi into 2 pi upon 4. So final answer is pi square. Okay. Next question, you have to solve this x sin x cos x upon sin 4x plus cos 4x. Okay. So here also we'll do the same thing, that is using the property. So this is pi by 2 minus x sin pi by 2 minus x cos pi by 2 minus x sin 4x pi by 2 minus x dx. Okay. So here they change, that is sin becomes cos, cos becomes sin. Dx. Okay. Now here also if you separate this will be what? Minus integral 0 to pi by 2 so this is nothing but our I, right? So this I will take this side, so it becomes 2I. Pi by 2 you can write outside. So now to remove this cos 4x and sin 4x. So here we'll divide numerator by cos raised to 4x. Okay. So that it becomes cos x upon cos x into sin x upon cos 4x cos raised to 4x upon cos raised to 4x cos raised to 4 is 1 and this is 10 raised to 4. Okay. Cos cube. So sin upon cos I can take 10 and the thing which remains is 1 upon cos square x, which I can write x square x dx. So here we can make substitution for 10 square of x. Okay. So 10 square x derivative is 2 10x into derivative of 10x, which is x square x dx dt. Okay, so we get the numerator term. Here also you have to make the substitutions. That is, you have to change the limits. So when x is 0, t is tan of 0, 0. X is pi by 2. So tan 90 not defined, so it is infinity. Okay. And we have to take dt upon 2. Integral of 1 upon 1 plus t square tan inverse. Four and this 2, so 8. So this is 1 upon 0, so not defined. T is of pi by 2 and 0 is 0, right? 16. Next question. Integral x square sin inverse of x 1 plus x square is to 3 by 2. Okay, so we can remove this sin inverse by substituting x as some sign, right? So we'll substitute x equal to sin t cos t dt. Okay, so this becomes sin square t sin inverse sin of t dx is cos t dt upon 1 plus, this is 1 plus or 1 minus, this is okay. Okay, in place of x square you have to put sin square t. This is t. Okay. 1 minus sin square t is cos square t raised to 3 by 2. So cos square t, we can write cos t raised to 2. Okay, into this is raised to 3 by 2. So this 2 and 2 gets cancelled. Okay, one of the cos also gets cancelled, so we'll get sin square t upon cos square t, which is tan square t. Now we don't have a direct integral of tan square t, right? So we can write this as 1 plus 1 plus tan square t is right, because 1 plus tan square theta is sec square theta. Okay, so tan square theta we can write sec square theta minus 1. So this you have to integrate by parts. T integral of sec square t dt is tan t minus integral into derivative of t1. This is our t square by 2. Integral of tan t log of minus t square by 2 plus c. Okay. Now we have to substitute the value of t. So x was sine t. So t is sine inverse of x. Okay, what about tan t? Same way. Sine t is our x upon 1. Okay, using the triangle method, opposite upon hypotenuse. So this will be root of 1 minus x square. Okay, so what will be the tan t? Opposite upon adjacent. Sec of t is uh, hypotenuse upon adjacent. Then t square is sine inverse of t by 2 plus c.